Everybody is talking about AI. But there's a world of difference between just messing around with a pilot project and actually getting real, scalable value out of it. And frankly, a lot of companies are getting stuck. So in this explainer, we're going to break down a really powerful framework for AI delivery. Think of it as an operating system designed to turn all that potential into actual performance. All right, let's dive in.
And look, this statistic from Porsche Consulting tells you everything you need to know. It just lays it all out there. There's this massive, massive gap between what companies hope AI will do for them and what they're actually getting. We're talking a nearly 60-point difference between expectation and reality. That's a huge sign that the way most organizations are trying to ship AI, well, it just isn't working.
So that begs the really big question. Why is this happening? Porsche Consulting has a great name for it, the AI pilot trap. You've probably seen it. Companies launch these exciting pilots that show a little bit of promise, but then they just can't seem to turn them into real, productive solutions that work across the whole company. The projects just get stuck in this loop, and the value never shows up. Sound familiar?
The way out of this trap isn't more hype. It's structure. The real antidote here is a concrete, enforceable playbook. It's all about moving away from decisions based on who tells the best story or has the most political clout, and moving toward a system that's built on cold, hard evidence and crystal clear accountability.
The official name for this kind of playbook is an AI operating model. You can just think of it as the master plan for everything. It defines how your people, your processes, and your tech all come together to deliver AI that actually works. And the most crucial part is that it forces everything to align with real business goals and makes it absolutely clear who's on the hook for the results.
And this is where you can really see the difference. The old way, narrative-based politics, that's a world of chaos. Nobody's quite sure who's responsible for what. Approvals depend on who you know, and when it all goes wrong, you just get a bunch of excuses after the fact. The new way, the evidence-based system, is all about discipline. Ownership is explicitly named, progress is controlled by strict checkpoints, and every single decision is backed up by proof you could take to an audit.
So if that's a system, who actually makes it all happen? This is where the model gets really specific about the people and their roles. And it all starts with a very small, very powerful core team.
Right at the very heart of this operating model is what's called the agentic trio. Now, forget about some massive, slow-moving committee. This is a lean, empowered team of 3, where each person has total ownership over one critical piece of the puzzle. The product manager owns business viability, asking, is this worth doing? The design lead owns user trust, and really importantly, what the experience is like when things go wrong. And the architect or engineering lead owns the technical side. Is this even possible to build, and have we put the right safety controls in place? That last part is so critical, because agentic AI can fail in some really dangerous ways.
And the work itself is split in a really smart way. Every single project is treated like a binding contract between 2 separate streams. On one side, you have the capability or invention stream. That's led by engineering, and they're focused on building reusable tools and safety controls. On the other side, you have the application or outcome stream. That's led by product, and they're focused on using those tools to solve real customer problems. And here's the golden rule. No project moves forward without a verified link, a signed contract, if you will, between these 2 streams. No more building tech for tech's sake.
Now we get to the real engine of this entire system, the non-bypassable evidence gates. This is where the model completely breaks from your traditional agile roadmap, which, let's be honest, can easily get derailed by politics. These gates are strict, sequential checkpoints. They are not suggestions. They cannot be bypassed. They are specifically designed to force rigor and to kill costly, bad ideas before they get out of control.
It all kicks off right here at Gate 1, the problem gate. Before a single line of code gets written, the team has to prove with actual evidence that the problem they're trying to solve is real, that they know how to measure success, and that every requirement can be tested. This one gate almost single-handedly stops all of those "I have a cool solution, now where's a problem" projects dead in their tracks. Next up is the cost hypothesis gate. This is a critical economic reality check. The team has to prove there's a believable path to actually building the thing, and, just as importantly, they have to estimate what it will cost, both to build it and to run it. This is what stops the organization from chasing after shiny projects that are pretty much guaranteed to lose money from day one. Okay, so once a problem is proven to be real and financially viable, you hit the concept gate. This is where the what and the why get locked down. The team has to agree on a defensible architecture and define the system's permission envelope, what it's allowed to do, what it's allowed to access, and they have to do it before any major development work starts. The verification gate is basically the show-me stage. By now, the team has built a prototype, and they have to prove that it actually works. And I don't mean a slick, canned demo. We're talking about a rigorous test of the core tasks, a stress test of all the weird edge cases, and a confirmation that every single one of the safety controls works exactly as designed.
So, before a project can get anywhere near a real user pilot, it has to pass the cost and capitalization gate. Remember those cost estimates from Gate 2? Well, here, those theoretical numbers get thrown out and replaced with measured, real-world unit economics from the prototype. Hard budget controls have to be put in place. This is what protects the business from launching a product that looks great in a demo, but secretly collapses under its own operating costs.
And finally, after a pilot runs, you have the outcomes review. This gate is the ultimate test. You look at the data from real traffic, from real users, and you evaluate the solution's actual economics and adoption. And based on that hard evidence, a final decision is made. Do we scale it up? Do we iterate on it? Or do we kill it and move on?
Now, a system this discipline needs a way to keep itself honest, right? You can't let politics or pet projects find a way to bypass the rules. So the model has specific governance functions built right in to protect the integrity of the whole process.
And a huge piece of that is the control tower. This is a totally neutral function, often run by a group like Product Ops, that isn't aligned with any single team. You can think of them as the air traffic controllers for the entire AI portfolio. They enforce the rules, they make sure meetings happen when they're supposed to, and they do completeness checks to make sure nobody is trying to squeak through a gate without all the required evidence. And this is a brilliant mechanism for fairness. It's called the innovation ledger. And what it does is structurally prevent credit capture. You know, when someone swoops in and claims credit for work they didn't do? Here, every contribution is logged and linked to unchangeable evidence. The people who actually invented the tech are credited through things like design docs and code commits. The people who productized it are linked to the release notes. And the people who scaled it are tied directly to the adoption dashboards. The evidence speaks for itself. So when you put all these pieces together, the trio, the value streams, the gates, the governance, what you get is a fundamental shift. You move AI development out of the world of hype and into a true engineering discipline. So let's just recap the tangible achievements this model delivers.
When it all comes together, what have you really accomplished? Well, it boils down to 4 key achievements. First, economic viability. You protect the organization from deploying AI that will literally collapse under its own inference and tooling costs. Second, rigorous discovery. You force teams to prove a problem is valid and worth solving before they start building. Third, fair attribution. That innovation ledger makes sure the right people get the credit, period. And finally, and maybe most importantly, built-in safety. It makes hazard analysis a mandatory part of the design process from day one, not some afterthought.
And that leaves us with one last big question for you to think about. Take a hard look at how your own organization is building and deploying AI. Is it being driven by hype, by narratives, by politics? Or is it built on a disciplined, evidence-based, engineering-grade operating system? The answer to that question could be the very thing that determines whether you finally escape the pilot trap or stay stuck in it for good.